Hi, everyone. Thank you for joining us for today's webinar, Turbocharge Your Functional Test with 8 Lines of Code with Senior Architect and Evangelist Gil Tayar. If I have to talk about all the amazing things Gil has achieved and accomplished in his career, it would take us more than the hour we have allocated for this session. So I'll just give you the highlights. Gil is a Senior Architect and Evangelist at Applitools. He has over 30 years of experience with software development. He has co-founded Web College and worked on some of the largest projects at Wix. Gil is also a sought-after public speaker, and he frequently talks at notable international conferences about test automation and software development. He just came back from Selenium Conf India, and you can catch him at Star West at the beginning of October. So I suggest we let Gil do the talking now. Gil, take it away.
Thank you, Adi. So yeah, you're almost there. Let's turbocharge our functional tests in 8 lines of code with visual powers. Okay. So you've already heard about me. I'll skip that slide. So first of all, I want to establish a baseline. We'll be talking a lot about image baselines, but first I want to talk about terminology baselines. What are functional tests? When we're talking about turbocharging them, we first need to understand what they are. So what are functional tests? Because there are so many kinds of tests. In terms of terminology, people talk about unit, integration, end-to-end, acceptance, visual, contract, browser, automation, functional. The list goes on and on and on and on and on and on. Not only that, when two people meet and talk about whatever, contract test, a browser test, automation, functional, each one has a different interpretation of that term. So what I want to do is talk about my definition of functional tests. Let's, even if you disagree, and probably a lot of you disagree, let's take it as the baseline for this talk. So from my point of view for this talk, functional tests are automation tests that automate the browser, and in this case, or a mobile browser or a mobile phone, in order to test the functionality of the application. And the important thing is it's a test that automates the browser, and it tests the functionality of the application. So it tests whether the application works as expected. So those are functional tests for the purpose of this presentation. So let's, this is, we need to turbocharge. Let's write a functional test. And I'm a huge fan of JavaScript. I believe that a really good tool for writing tests, automation tests, is JavaScript. These are some of the benefits of JavaScript and Node.js, and also a lot of the cool new automation frameworks are written in Node.js. If not, yes, we do have Selenium WebDriver, but we also have frameworks like Puppeteer and Cypress that are joining the JavaScript framework area. And the important thing, I think is the most important thing, it is the language of the front-end developers. So you will be able to write tests with the front-end developers, and you will be able to share code between yourselves and the front-end developers. So that's my little pitch on JavaScript. And let's first of all take a look at the app we're testing before writing a functional tests. So let's look at the app itself. So I will do an npm start just to show the app. And what npm start is, it's going to start the application as a Docker application, but in your case, the application may be running in staging or on some kind of a test server. Now we will open a new tab and do a localhost 3000. Oh, not that one, that one, yes. So this is a blog app where you can sign up, put in a username, whatever. Username is Gil Tayar, the email is whatever, and the password is this and this and this and this. And now we can add a new post. The article title is whatever, and we publish the article, and on the home page in the global feed, we can see that article. We can also add comments to the article, etc., etc., etc. So it's basically a blog app, and we want to test that app using functional testing. So let's write a functional test in JavaScript. Oh, sorry. So I'll close the application. I'll even erase it totally from Docker. And to remind me, I have this set of instructions. Okay. So first of all, we'll start with an empty. We'll start with an empty file, and we'll build a scaffolding for a Mocha test. Mocha and Chai are test runners. Mocha is the test runner, which enables us to write tests in JavaScript. I use Mocha. A lot of people use Jest. Those are the two main frameworks running in JavaScript. So what else do we need for a functional test? Besides Mocha and Chai, we also need Selenium WebDriver and Chrome Driver. Those are in the node modules, so they're already pre-installed, so we're good in that area. And we created the scaffold. Now let's add a Selenium WebDriver. So we say WebDriver equals require Selenium WebDriver. And we will require the Chrome driver, which will do two things. It will run the Chrome driver, the Selenium Chrome driver, and it will run Chrome itself. You don't need to set it up beforehand. The Chrome driver and NPM does all the heavy lifting. You can have it not do it, but by default, it will. So now we have Selenium set up, and we will write the test. And what we want to do is write a test that checks that there is an error if we leave the email blank. That is the test that we want to write. So, but before we want to write the test, we want to start up the browser. So we will write a before function, which runs before all the tests, and we will use WebDriver to WebDriver builder to run Chrome.build. There we go. That's the before. This will run Chrome itself.
Gil, I'm sorry to interrupt in the middle, yes, but some people have requested to maybe if you could zoom in on your code a little bit, because it's a bit small.
Definitely. I am sorry. I usually do that. I totally forgot. There we go.
Thank you very
much. Thank you, Adi, and everybody for mentioning that. So, is this okay? Yeah, definitely. If we'll need to zoom back.
Yeah, this looks good. Yeah, this looks fine.
Great. Thank you, Adi. Okay, so after, we need to add here before and after. And after we need to close and we need to put it inside a driver, variable. And after, we want to close the browser, so we quit the driver, and that will close the browser. That's the easy part. Now let's write the test itself. The test itself wants to, first of all, navigate to the register page. There we go. Please ignore the async await thing. This is a JavaScript thing. I don't want to delve into that because this is not about JavaScript. This is about functional and visual tests. But I do a navigation, a driver.get to the register page. Now what I want to do is to enter the username and password. But first, I want to wait until the element is located. Until the input of the username is located, that will probably mean that the rest of the page is already up. So I need until and by, so I take them from WebDriver. There we go. Once the page is up, I can grab the username field using CSS selector, and then send the keys and choose a username, which is called a username. I'm not very imaginative here, sorry. And the password, same. I will find the password field and send the password a password. Obviously, we do not want to touch the email field because the test checks that there is an error if the email field is blank. Perfect. Now we want to click the submit button. So we find the element, the submit button, and then just click it in the regular Selenium WebDriver way. Great. Once we did those actions, we want to validate the result. And how do we validate the result? First of all, we wait for that element, the error message, to be there, and then we find it and look at its text. If it includes email can be blank, we are good. So expect the text of the error message to include email can be blank. This is our test. I hope it will run. Are the demo gods with me today? Okay, so I do npm test. This will run the Docker with the app and then run the Mocha test. This is the only test that is running, and then when it's done, it will kill the Docker application. So there we go. Docker, it's running the application, and now there we go. The test passed. We didn't see the Chrome browser because everything is behind everything else. If I wasn't full screen, then you would have seen the Chrome browser. Sorry, doing the animation. So that's our first functional test. This is great. I did it. Okay, so let's talk a little bit about functional tests. And from my point of view, all functional tests are stories. Do this, do this, do this, and then verify something, then do this and do this and do this and verify something. They all look like this. Action, action. In our case, it was set the username, navigate, set the username, set the password, click on submit. Those are the actions. And then validation. The validation is check that there is an error message, email field can't be blank. And then another action, and then another validation. And while in unit tests, people tend to write small tests, each one independent of the other. In functional tests like these, because these tests are usually slow, we don't want to build the setup again and again and again. Functional tests are usually longer and test a lot more things in one bundle of a test. So we always have action, action, validation, action, 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 validation, etc., etc. Sometimes the test takes minutes to run. But let's build such a test, which is like a bit more complex. And for that, I will not write it because it will take a long time. I will just go to a specific commit, which already has the test in it. Step 2, sorry, not step 1. There we go. And it includes a test, which we will talk about now. Let's do the following. First of all, the code, we will create some utility functions just so that the test will be nicer to read. The first utility function is wait for. You give it a selector and it waits until that element exists. The second is set text, which types in some text into an input. Click, again, clicks a button given a selector, and get text gets the value of that selector. Really, really simple utility functions. They will just make our code nicer to read. And then the first thing we want to do is we want to hold a story here. So the first thing we want to do is sign up, register a user. There are 3 actions: a username, email, and password. And the 4th action is the clicking of the button. And this is basically how it looks. I navigate to the register. We already saw that. Set text, set text, set text for the username, password, and email, and then click on the button. Even here, we're starting to see a problem, which we are all aware of as testers, the fragile selector problem. These, well, actually the first one is an error. That's not a selector, it's just a URL, that's fine. But all the others are selectors. Okay, and the problem of the fragile selectors is that developers change those constantly, and they are changed not only because developers are they do whatever they want, but because the application itself changes, and that's a big problem for everyone. But there are your solutions. We already know what the common solution is, which is an object, a page object. We define a class with a page object, and that page object defines logical actions, like register user in our case, which gets logical parameters, and it knows about those selectors. So that if I have a lot of tests that do register user and the page changes, not a problem. I go into one place, do those changes, and all the rest of the tests will work. That is common practice of using page objects. That basically solves the fragile selector problem for actions. Now, once I clicked on the submit, I will get to the home page. That is how the application works. And here we need to validate that the home page looks correct. So I need to validate that the tab is the Your Feed tab here. And the no articles are here yet exists because we've only just registered, and that the username is correct, and that the actions, and that the username is correct. And we need to click, as an action, we need to click on the post. So here we have validations. And how do validations look like? Well, how do we validate the username? We get the text of the username using some selector and check that it's true. And then we validate the articles list, okay? And check that the articles list has a no articles are here yet, etc. And validate that the active tab is the correct one. That is regular validation. And here also, we have the fragile selector problem. But both in actions and in validations, we have a fragile selector problem. But in this case, and we'll see that later, we could also do it in the page object. But here, it becomes a bit more interesting, and we'll talk about that later. How the page object paradigm doesn't really solve the fragile selector problem for validations. But let's continue. We validated the home page, and then we click on the new post and publish an article. So we have an action that sets the article name and the article whatever and the article text and the tags, and then clicks on the article button. These are all actions, and we've seen how actions are implemented. So this is the published post. I won't delve on it too much. We click on the new post, and then we set the text, and then finally click on the button, on the submit button. And again, we reach the article page. In the article page, we have lots and lots of validations. We click that the article name is correct, and the username is correct, and the time is correct, and the text is correct, and the tags are correct. And then we do some action, and that's how a validation looks like. But we also need to add a comment in the comment text and validate that that comment is true. Now this starts becoming tricky. What if we want to validate two comments? Then we need to go over the array and look at it and start validating more and more and more stuff. This is starting to become problematic. The more complex the page is, the more validations we need to do. And the ultimate example is checking that the homepage is correct after adding a post. We have so many validations to check for that it becomes really long validation. Moreover, nobody assures us that we've validated everything. We validate what we know, but we don't validate what we don't know. So in this example, maybe some other kind of element appeared in the page and is wrong, and we forgot to validate it, or something was added to the page and we didn't know about it, and thus we didn't validate it. So in terms of actions, we know what we need to do, but in terms of validations, there's so much to validate, and we don't know everything we need to validate. So we have problems with the actions, fragile selectors, complex code, and the solution is pretty basic, page objects. Validations, we have fragile selectors in complex code, and that can be worked with page objects, but there's too much to validate, and we only do positive checks. We don't validate what we don't know about. So the solution here is page objects, but it's not really a solution. It's not a file solution. It's good enough, but we want to be better. And the problem here, if we want to understand, is that actions are focused. Click this, do that, whatever. But validations on a big web app, on a map, are holistic. We need to check the whole page. That is why focused actions can be solved with page objects, but validations are problematic because they need to check everything. And to understand why validations are holistic, let's add a bug to our code. I'm not talking about the testing code. I'm talking about the developer code, the application code. So let's go to register.js. This is the code that deals with the registration page, and add the following line. There we go. I'm not going to go into this. This is a React application, but what it does is that when you submit the form, it also updates the username with a blank value. That's the username with a blank value. And let's assume that the developer added that as a bug mistakenly. This is a bit artificial, but it's okay for our purposes. And let's rebuild the application. That it will compile the front end and then generate a front end and the back end Docker image. And there we go. And let's run the test. Will the test pass? And let's think about it. Did the test check the username field? No, it checked the home page. It checked just the error field. It just checked that there's an error. Email can't be blank. So basically, the test passes because it's not checking everything. Okay. So let's change our. Well, wait. I wanna remove that bug. Sorry, and rebuild so we won't get it back. Okay. Sorry. So we need to change our statement from previously. Actions are focused, validations should be holistic. Currently, if we write functional tests the way they are usually written, they are not holistic. They are focused as the actions themselves, but they should be holistic. Okay, then we already reverted the bug, so let's try and think how to solve the validation problem. And to understand, we need to solve it. We need the validations to become holistic. But what else is holistic? And the answer is vision. If we could manually, as humans, as people, look at the home page and validate, or whatever page, and check it, we could do a holistic validation. As humans, we can look at the page and say, hey, wait a minute, this is wrong, even though we don't really need to go each and every little thing. We can look at the page holistically and figure out that there's a wrong thing. Unfortunately, there are two problems with that solution. We're back to manual testing, which is the major problem, but also humans tend to be flaky. We miss things a lot, we get bored, etc., etc., etc. So vision is the solution, but we're not there yet because we don't know how to implement that solution. And the answer is, it's a very simple answer. We'll replace humans with image diffing. And let's do some live coding for that. And the idea is very simple. If we, on the first run of the test, take a screenshot of the page and save it somewhere, then in the next runs of that same test, we can compare the images to see that they are correct. So let's do that. And for that, I will go to step 3. There we go. So let's look at the functional test. Functional test has changed. First of all, we added an import require in JavaScript to a library called Chai Image Assert. It's a plugin library for Chai for testing images. And now, and also, we added a new function, a check window. Check window gets a base image name and it takes a screenshot. Here it is, using Selenium WebDriver, and then ignore the buffer from, this is just an implementation detail, expects that image that we took a screenshot to match the image base name. What Chai Image Assert will do is, if it will check it against a baseline image we saved previously. Let's run it the first time. Oh, obviously, in the test, we also added check window to check that window, to check that screenshot in the end. So let's run the test. npmt is a shortcut for npm test. And we're running the Docker images. It's going to the registration page. For some reason, I'm seeing the pages, and it failed, which is fine. Why? Because this is the first run. Registration blank email error. I go to registration blank email error, and this is the page. Now I take this because I checked it, it makes sense. I take it and go to the expected screenshots and copy it there. Now when I run the test again, it will take a screenshot, compare it to the same screenshot in expected screenshots, and succeed. Let's ignore the second test because it doesn't have the images for that. And succeed with the test. This is great, this is what we wanted. But now let's go back to our bug and change it and return it to, oh, the line. Do we have the line? Yes, I still have the line in the clipboard. This is fine. Okay, we add the bug. So now when I submit, it will blank the username. So that's a bug. And now we will build the application again with the bug. This will take less than a minute. Remember, the bug is that when we submit the page, it will show the error, there is no email, but it will also blank the username field. Now let's run the test. We're running the test. It's, for some reason, showing the Chrome, and it failed. This is exactly what we wanted. This time, the validation, because it was a visual validation, it was holistic. So this is the new screen. As you can see, the username is blank. The expected screen is this one where there is a username. And Chai Image Assert also does a nice thing. It shows us the visual difference between the two. It shows us one, it's supposed to be a username, and the other name, it's supposed to be the placeholder username. So the test failed, even though we didn't check for that specific thing. Because visual tests are holistic, we're checking things we don't even know about. We're also checking what we wanted, which is email can be blank. But we're checking things we don't even know that we're checking, which is great, which is exactly what we wanted. Great. So we've replaced one validation, which is checking the error messages to include email can be blank, with another one, which is expecting the screenshots to be the similar one to the previous screenshot. That's not better. That's just one line replacing another. But it is better, as we said. It solves the fragile selectors problem. I don't need any selector for validations. There is no complex code. Whatever I want to validate, it's the same line of code. Take the screenshot, compare it to the previous test screenshot, to the baseline screenshot. There's too much to validate? Not anymore. Just one line validates everything on the page. Only positive checks. We can only validate what we know about. Not anymore. It's validating all the page, even things we didn't think of validating. So visual validations solve the problem of functional validations, not to check how the page looks like, but to check that the functionality is working correctly. We tried it out, and we're done. And I want to take the chance to revert the bug. And npm run build. So we won't find the bug again. So we've seen that functional validations are still focused, but visual validations are holistic, which is exactly what we wanted. And we've changed this validation of the post as an example of a validation we did earlier, which checks that the title is correct and the article content is correct and the tags are correct and whatnot. We've changed it into just one line, check window, we're done. And we've changed this long code, which checks a lot of stuff in the home page and clicks and checks the post page, into check the home page, click, and check the other page. It's that simple. We've changed a long list of validations into one line of code, and we've solved the problem. No more selectors, same code for all validations. We validate holistically, and we validate things we didn't even think of validating. But there's problems in perfect land. Nothing's ever that simple. And why is that? Because image diffing is naive. One does not simply do bitmap comparison. Try image assert and most of the tools on the market, both open source and commercial, do image diffing in a naive way. They check the pixels. But the problem with checking the pixels is that not one screenshot is different from another. If you're running the test locally, you will find small anti-aliasing differences between Mac, Linux, and Windows, between one version of Windows to another. Different GPUs will generate different images. Moreover, we've just seen it in Chrome 67 versus Chrome version 68. The same image was rendered differently in Chrome versus 67, Chrome versus 68. So we will have a blog post about it in our blog in a couple of days. So if you check, you look at it, it's the same image, it's the same dog image or whatever, but if you do a naive pixel comparison, you will see that all of the pixels have changed, or most of the pixels have changed, but it still looks the same. So that's a big, big problem with pixel comparison. There are daytime problems. There are regions that are different from run to run. So we have a date there and everything worked because we're running all the tests today. But if I run that test tomorrow, the dates will be different and I will get a problematic image. So I need to define ignore regions, which I ignore based on X, Y, width, height, based on various regions. So I need to programmatically put that in. What about full screen? Taking a full screen snapshot is not supported by Selenium, only viewport. So if I want a full screen validation, that's a problem. And as we said, comparing is a pain, and accepting a new baseline is a pain. If I have lots of differences, like I have 100 screenshots, and I have the same difference in the header in all of the screenshots, I have to check each and every one of them and then copy them from one folder to another, and those that aren't correct, not copy them. So it's a lot of folder manipulation and file manipulation, which is a big pain. So one does not simply do bitmap comparison, unfortunately. But there are cloud-based solutions, and the cloud-based solutions try to be better in lots of ways. And the two major ways is that they use visual diffing algorithms that see like a human sees. They ignore the small differences, and we're talking about AI level algorithms that keep getting better and better and better at that. And the screenshot management, because there's a GUI on the cloud that deals with the screenshots, it enables you to see the diffs in a nice way, approve the new baselines, even open bugs on diffs that are bugs, and even approve if I have the same change in the header for all the 100 screenshots, just approve them in one click. Let's try it out. Let's try it out, and as an example, we will be using Applitools. So I will git checkout step 4, which is git reset, and git checkout step 4, and let's look at the code. First of all, I will add the bug. I won't build it. I'm commenting out just so I won't lose whatever is in my clipboard. And let's look at the test. And the regular before and after that runs the Chrome browser is still there. No, we didn't change anything about that. We still need to run a browser. But we're also initializing the SDK of the cloud-based solution of Applitools eyes. We're setting the API key, and we're saying we're running a new test. And I will write here real world August 2018, so it won't interfere. It won't remember if I ran that test already with the name real world. And I'm telling it the size of the viewport is 800 by 600. I can do whatever I want here. Okay, and the regular thing is the wait for and the sec test, it's all regular, but the check window is much easier. Instead of asking Selenium to take that screenshot, we're asking eyes, the SDK. And the eyes SDK knows how to take a viewport screenshot or a full page screenshot, or even give it a selector and it will take a screenshot just for that selector if you want to do a partial visual validation. So it's as simple as eyes.checkWindow, and you give it a tag name, which is the name of the screenshot, basically. So let's run it. npm test and run. Oh, wait. Sorry. I will add the API key, and now we'll run. There we go. So what are we doing here? We're running the test. It's a regular Selenium WebDriver test, and when it reaches check window, and it hopefully will reach check window. Yep. When it reaches check window, it will first of all take a screenshot of that page. I think the default is full page, but I'm not exactly sure. Upload that to the Applitools eyes server on the cloud, and the Applitools eyes server will check it against the baseline. In this case, there is no baseline, but what Applitools eyes does, is it accepts that because it assumes that the first test is okay. You can always tell it it's not okay, but it assumes that the test is okay. That was, and the next time we'll run it, and we won't run it again we will try and make it fail. The next time it will run, it will again compare those two screenshots, one against the other, and check for visual differences. But this time, the visual differences that it checks are going to be as humans would see them. So the visual diffing is not bitmap comparison, but it will ignore all those small differences that are in the page. Okay, so let's go to Applitools eyes, eyes.applitools.com, and let's look at the management screen, the dashboard. And hopefully, yes, here is the test, and here we can see what operating system it runs on, what browser, and what the viewport is, and here we can see all the images, all the screenshots. The little plus here says that it's a new screenshot, never before seen. Perfect, and it's green because there's an assumption that the baselines are okay. We can see the baselines here if we want and step through the different steps. Okay, now let's make it fail. If I run it again, it will succeed. Not a lot to see, not very interesting. Let's make it fail. Okay, we run this on submit. We run the build so that we will build it with the bug. Remember, the bug is that the username will change. Okay. And we do npm test. We run it again. This time, the same thing will happen. Remember, It will do all the automation on the registration page. And when we do check window, it will take a screenshot of that window, full page, I think, and upload that to the eyes server. The eyes server will compare that against the baseline image, which we just uploaded in the previous test, which was defined as okay, and compare them in a I call it the human mode. It's called strict mode in eyes, but I tend to think of it as check it in a human mode, ignoring the little differences that a human wouldn't see. Okay, we will wait for it to pass. There we go. And let's go in the meanwhile and look at, there we go, we're almost there. And okay, let's look at the test. There we go. We have a new test on this with the same test name, but it's unresolved. Why is it unresolved? What it is saying to us is that all these are green, these passed, all these screenshots passed, but this one, it doesn't know whether it's a bug or a feature. Let's look at the differences, and I'll remove the pink thingy. As you can see, there's the baseline and the checkpoint, and there is, I will do it slower because we're on the internet. And we can see using pink or all the cool animations that Applitools has, we can see the difference. But what it's telling us is that it's not necessarily a bug. Maybe it's a feature. Maybe there's a new button, or maybe the difference is okay. We need to tell it whether it's okay or it's a bug. If we tell it it's a bug, then okay, it's a bug, and the test failed. But if we tell it it's okay, what we're basically telling it is that this is the new baseline, okay? And this test passes, okay? So we can do two things in baseline management, either in test management. Either we fail the screenshot, meaning it's a bug, and we can use Applitools to open a gyro bug if we want, or we can say, no, this is a new baseline, and all the tests after that will use that new baseline instead of the old screenshot. It's much better than copying things from folder to folder. And I think we are almost there. We did that. So we've come a long way from writing a small functional test. Making it into a larger story, seeing the problems with actions, the fragile selector problem, which can be solved with patterns like page objects, and then saw problems with validations, which can partially be solved by page objects, but not totally, because we remember the actions themselves are focused, but the validations are holistic. And we saw a way to solve that using visual validations, either through open source pixel-based tools or through cloud-based solutions, some of which are use human validations, such as Applitools eyes. So how does one supercharge or turbocharge our tests with visual validations? One, we write code that issues action after action to create a long story. We already know that, how to do that. And then instead of the regular validations that check the value of a text field or the value of an H1 or a value of a span or a div, we just check the whole page using visual validations, either with open source solutions or with cloud-based options. And the nice thing about it is if you add visual validations instead of functional validations, you get 2 for the price of 1. 1, you get much simpler functional validations, as we saw. We can replace a whole page of validations with just 1 line. And 2, that's two for the price of one. You get a visual validation of your page. So if you have visual problems with a page, for example, some developer changes CSS and made everything mushy and different backgrounds and problems in visual stuff, you catch those visual bugs that you couldn't catch until now. So remember, if you have functional code, functional tests, and you have problems with your validations, one of the solutions is visual validations. Thank you very much. And I'm passing it back to you, Adi.
Thank you, Gil. Yeah, we do have quite a few questions. So we'll take it from the top. So first one, how to perform validation on multi-level dropdown like country, state, and country population? Should we validate just this dropdown has data or a list of states and states, for example?
In functional validations, you can use Selenium WebDriver to figure out what the values are. Another way is to use visual validations and just click on the dropdown. It will drop down the list, and then take a visual screenshot, but not of all the page, because you don't need all the page, of just that element, and it will always compare one of the screenshots to another. And if there are too many or too few options, then you will get an error, a failed validation.
Next one.
Yep. Oh, yes.
Yeah, sure. Is the image assert available for Ruby?
Oh, definitely. There. In terms of open source, there are lots and lots and lots and lots of options out there. All the major languages, all the major test frameworks have something that does image validation. As I said, they all do pixel comparison, and they have a tweak level. So you can say, yeah, I can live with 10% of pixels being wrong, being different. It's a nice way of doing that. The other option is to use one of the cloud-based solutions SDK like Applitools Eyes, and in this case, Applitools, as an example, has SDKs for all of the languages I know of, except Haskell. So we have SDKs for Java, Python, JavaScript, obviously, Ruby, and others, C# and others. Yes. Adi, is there next question?
Yeah. I'm sorry, I'm on mute, so it took me a second to unmute myself. Next question. Can I tell the Eyes API which section of the image to ignore, such as the value entered for a username and email?
Definitely. You can do two things. You can do it programmatically. So in the eyes.check window, you can say, and please ignore this region, and you give it an XY width height, or you give it a selector, which is fine. Or you can do it in the dashboard. We saw the management, and so what you can say is you can just use drag and drop and choose the region you want to ignore. It's much nicer. Instead of figuring out the XY width height of the region, it's just much nicer to drag and drop and create the region in the dashboard. That region will be saved along with the baseline images for future tests. Adi?
Next one. Can we compare a screenshot in one resolution to another?
Yes.
I mean, different resolution. Sorry.
Yes. Yes. There are two ways to go about it. One way is, as an example of Applitools, Eyes will have different baselines for different resolutions. That's the default. If you want to say the images must be exactly the same, you can combine those baselines. You can tell Eyes, yes, it's okay. Ignore the resolution and have all the resolutions be the same baseline image. That's okay, but those two screenshots must be exactly the same. The problem is that usually if you have different resolutions, your web page will be different because responsive design, things tend to stretch or not stretch. But if it's exactly the same screenshot, you can combine the baselines from different resolutions. I think that's it, Adi.
Can I test responsive web pages, and if so, how do I go about it?
In a way, it's funny that the previous answer is in a way an answer to that question. How do we check responsive websites? And the answer is you run the tests in different widths, and take screenshots for each one of those widths. And as I said, the baseline by default of each image of each resolution will be different. So the baseline for a 1K, 1024 by 768 will be different from the one for 400 by 600, an iPhone resolution or something. So that way you can do visual validations and visual testing for different resolutions of your responsive web app. I think that's it, Adi.
Can we use this for mobile native apps automation using Appium?
Yes, definitely. You can take screenshots using Appium, using the same API we saw earlier. And once you have that screenshot, open source tools, you can check that screenshot just like it checks a WebDriver, a web app. Or you can use Applitools, ICE, Appium SDK, and there are other SDK for mobile tests, and get the same result, but using human visual differences.
So we're getting quite a few questions. This is not like a one question. I'm just going to combine. So a lot of people are asking about comparing either not online images, but preview images, PDFs, SVGs, and comparing one format to another, and asking if that is possible.
Okay, so in terms of visual testing, we have an SDK, and I'm talking Applitools here. We have an SDK that gets the PDF and does visual validations of it. What it basically does is it takes a screenshot of all the pages, full page, or and then sends them to the ICE server. Same goes for, let's say, Windows apps. We have a Windows app SDK and lots of other SDKs. But if there is an SDK that we don't have, for example, for SVG images, and I don't think we have one, then if you have a way of taking a screenshot, we have the image SDK, which just, you generate the screenshot, give us the image, and we do the rest. So we have the generic image SDK, which will probably solve the rest of the problems, even if we don't have a specific SDK for that purpose.
So we have a set of questions about baselines, again, visual testing. Yeah. So the first one, we'll just take them question, answer, until we're done. How can I update existing baselines?
Again, if you're using open source tools, you just drag the file from the actual screenshots to the expected screenshots. Each tool with their own different set of folders, but basically that's the way to change the update the screenshot. In cloud-based solutions like Applitools Eyes, as I showed, it will show a difference. It will show that there's a failure in the test in the dashboard, and you just click on yes, this is the new baseline, which in Applitools is a thumbs up. Once you say that this is a good screenshot, Applitools will update the baseline so that the next tests will use that baseline as a baseline image. So that's how you update the baseline.
Second question regarding baselines. How can I download all existing branch baselines?
Oh, wow, that's a very, very specific Applitools question. First of all, how do you download a baseline? Again, there's Command I or Control I think, in Windows, which just shows you the image in a new tab, and then you just use Chrome's or Firefox's right-click, save image as, and download it as a PNG. As for branches, you go to the Applitools dashboard, find out all the brand, and take the branch baselines. I don't want to get into exactly how to do it, and then one by one do what I mentioned earlier, which is show the image and then download it. Yes, Adi.
Yeah, and the third question regarding baselines, and again, I think it's an Applitools specific question. How can I delete existing baselines using the code and not using the UI?
Interesting. Using the code, I'm not sure about that. There is a REST API that can be used. Please contact Applitools customer success, Applitools support, and they will send you the documentation. The REST API enables you to basically do whatever the dashboard application does, the test manager. So if the test manager can do it, the REST API can do it.
Wonderful. Yeah. So another question, I like that one. Is it possible to test end-to-end journey? For example, I'm paying my credit card bill, click on payment button, next page is to choose full payment or partial payment, and then which bank, then confirmation page. So there are a lot of dynamic pages in the process until the transaction is completed. So is that possible to test?
Definitely. And again, what was described is a functional test. Yes, it's an end-to-end test, but that's fine. A lot of functional tests are end-to-end tests, and it's great. So what you do is you do the actions and then do a visual validation using check window. More actions, visual validation using check window. Now, I think what concerned you is that a lot of those pages are totally dynamic, so you don't really know what parts of those pages will have as values. And that's fine, because you can use either ignore regions, which say, please ignore that data, or layout regions, which say, look just at the visual layout of the page and ignore the data itself. So definitely you can use visual validations to check dynamic pages. It's being done constantly by many people. Yep.
Wonderful. Yeah, so I think that we'll take maybe just one or two more questions because we are out of time. So next one, do we have to use JavaScript for visual testing?
Oh, no. As I said, I'm a huge fan of JavaScript, but you don't have to be. It's fine to use Python, Java, C#, Ruby, you name it. There is the ability to do visual validations in all these languages, definitely.
Awesome. So last question for tonight. Is it possible to test a scenario that an action needs to open a new tab and validate the tab?
Definitely. From what I recollect, you switch to that tab using Selenium WebDriver. Once you do that, all the check windows will operate on that tab and take screenshots on that tab. So that's not a problem. Yes, you can definitely do that.
So, yeah, sorry.
I think that's it.
Okay, so unfortunately, that's all the time that we have for today. I want to thank everyone that joined us for this live session, and of course, to thank our speaker, Gil Tayar. I will mention two things. I know there are a lot of questions unanswered, and as I mentioned at the beginning, Gil's team will answer you via email. So I'm going to leave the questions open for another, 30 seconds to a minute. So if you have any follow-up questions, you can still ask. The recording will be emailed to you by Friday. So look out for that. And of course, I've seen all your thank you notes to Gil for this in-depth presentation. This was just a QA session, but I promise that he will see all of your thank you notes to him. So thank you for sharing that, and I'll make sure that he gets all of those. So I think this is it. Thank you.